Hi, I'm Mark Palmquist. Just going to go over this invention that I made. I'm going to test. It's a working model. It's not a final model, but let me show you what it is. So this is a foot-powered, dual-finned, basically fish propulsion. I have 25 degrees of swing left to right, and over here, this is where you push it with your feet. The resistance is by bungee cord, so you push it forward, these sweep inward like this, and then the bungee cord has tension, so it brings it back. So all the work is pushing. So you're using your largest muscle group. Basically, your legs pushing are 3 times stronger than your arms pulling. So that's one advantage that you have. The fact that you have 2 tails means that your board won't be wiggling, or it won't be going like a porpoise either. This is a box construction. This would be made out of tubular aluminum. This would also be tubular aluminum to cut down on weight. Right now I have a washer in here and a bolt, and there's a lot of friction going on right here, so I have to figure out how to reduce the friction here. This unbolts from this. These are actually, well, they can be cup holders, but that's where you reach the bolt and you can unbolt it. This arm would probably be detachable as well, so that it can fold for easy flat packing. The width is 60 inches, so that's 1.5 meters wide. The range, I designed it around the same range as a bike, which is 13 inches diameter. So between here and here is 13 inches. And this length is exactly, if this is 1, this is about 1.4. So the length, the sweep of the tail is about 18 inches. The reason for that is, so for this to work efficiently, this has to move at a rate more rapid than the forward velocity. So this has to go pretty fast, and that's why I chose that ratio. The other thing is these tails are not flexible. I mean, the hinge makes them flex, and that changes the angle of attack with the unflowing water. Now, I don't know about this angle, but right now it's 25 degrees in either direction, which adds up to 50 total. But I don't know if that's like the ideal or not. I have to test it and find out. I could always put rubber bumpers in here and reduce the angle to 20 degrees left and right, and then test that and see if it goes slower or faster. Also, you'll notice that these foils are vertical. They could be swept backwards at an angle like that. The problem with that is then I would have to have a fence, because you get cavitation, air would suck down more easily. So right now they're vertical, and you could also have it angled forward about 5 degrees or so, and that would also reduce cavitation. The problem with that is then you might catch more weeds. So I didn't want the center of mass to be in front of the hinge, because if you move it too far and it's right on the hinge, then the feathering action might be stalled. So right now it's just vertical. And the key is to keep this thing from twisting, so that's why solid ash, 30 millimeters square, is about the same strength as tubular steel, of the same dimension as far as resisting twist. So this should be pretty rigid, resist, going that way, twisting that way. Oh yeah, this bungee cord, I added it. It's not really necessary, but it kind of keeps these things from swinging out. If I take this out, then these arms swing out, and it's kind of clunky. So with this, it kind of helps it get back to the neutral position. So you're literally just bouncing the pedals. You're just bouncing them with your feet, and they kind of go back to. So it's going to look like that, basically. And the seat is relatively low. It actually could be lower, so that the butt and the feet should be basically on the same plane. Your bottom could actually be a little bit below. That would make it easier to pedal. But right now, I'm just using a beach chair, and I think having a lower center of gravity would be better. This is an old windsurfing board. It has a slot for a center board, and I just basically use that to lock this in place. I just basically put a short fin in there and glued it to this, so that keeps this from falling off. But this could be strapped on with two ratchet straps, basically, and you know, this is not a commercial work. This is just a working prototype, but it could be turned into a commercial product, all anodized aluminum. And that's about it. We'll see how it works.